Welcome to the Deep Dive. We're here to cut through the noise, bring you the core ideas, the really compelling stuff. And today we're diving into something pretty groundbreaking, I think. It's called Sophimatics. No, this isn't just another tweak to AI algorithms. It's framed as a whole new philosophical approach. The aim: to build ethical, genuinely human-aware AI right from the ground up. So for this deep dive, we've pulled together quite a range of academic sources. We're looking at foundational work by Gerardo and Giovanni Avani on Sophimatics itself, but we're also bringing in insights from recent research names like Langlois, Rowley, Lange, Jeha, and Rushby, Bundy. Quite a lineup. Our mission here really is to unpack how blending deep philosophical thinking with cognitive science and cutting-edge computation could lead us to AI that's more than just smart. We're talking ethical, adaptable, truly interactive AI. Moving past where we are now.
Okay, let's unpack this. So to really get why Sophimatics might be needed, we should probably start with the problem, right? Where do current AI ethics approaches sometimes? Well, fall short. Right now, many frameworks seem to be lists.
Lists of principles. Don't be biased. Respect privacy. Important, sure, but maybe not enough.
That's exactly the issue. It's often a surface-level application. What's fascinating, and Langlois and their colleagues really highlighted this recently, is that these conventional approaches often miss the mark on true interaction. They don't really allow for genuine, meaningful engagement between humans and machines.
It's like having the rules, but not the understanding behind them.
Precisely. You can follow a rule like be fair, but if you don't grasp the context, the nuance, the human element, you can't truly interact ethically. It remains quite brittle.
Okay, that paints a clear picture of the challenge. So if that's the problem, how does Sophimatics propose something different? What is it, essentially?
Well, think of Sophimatics as an interdisciplinary junction point. It's where philosophy, cognitive science, and computation are designed to meet and really integrate. Instead of just bolting on ethics rules after the fact, the idea is to weave moral, contextual, and interpretative values right into the AI's core architecture.
How does that work in practice?
It leverages some quite deep philosophical concepts, things like intentionality, which is about the AI's purpose or what it's about, and dynamic ontology.
Dynamic ontology, meaning its understanding isn't fixed.
Exactly. It can adapt its fundamental grasp of reality, not just stick to predefined labels. The aim is to get beyond simple rule following. It's about embedding principles like human-machine solidarity, sustainable development ideas, echoing things like the Montreal Declaration right into its operational core.
Now, this next part sounds, well, almost science fiction, but fascinating. The idea that AI could interrogate its own beliefs, is that really what Sophimatics is aiming for?
That's the ambition. It's about translating these sometimes abstract philosophical categories into actual working AI architectures. So ethical and interpretative capabilities aren't just add-ons, they're part of the AI's cognitive machinery. And yes, the goal is systems capable of self-evaluation, of dialogic reasoning, having a kind of internal dialogue and scenario reasoning.
Which you'd need in complex situations.
Yes, absolutely. Especially where moral factors and context shift constantly and fixed rules just break down. Epistemologically speaking, this means the AI can actively interpret, revise, maybe even question its own beliefs. It avoids that rigidity you see in many current systems. And as Langlois and the others argue, this reflective ability is key for AI to stay relevant and, frankly, adequate for society as we evolve.
Okay, the vision is incredibly ambitious, self-questioning, adaptable AI. But how? How do you actually build something like that? What's the technical core here?
Right, the technical foundation. A lot of this rests on what are called hybrid symbolic-connectionist models.
Hybrid, meaning mixing different approaches.
Exactly. So you're not just relying on symbolic AI, the classic rule-based stuff like logic programs, and you're not just relying on connectionist AI, neural networks, deep learning, pattern recognition. You're blending them.
Combining the logician and the artist, maybe?
That's a good way to put it. Research going back to Rowley and Lange in the 90s showed that this blend often gets superior results for really complex cognitive tasks, especially things needing deep abstraction. It tends to outperform using either system alone. Rowley's work, for instance, showed a hybrid system was much better for recognizing 2D images.
Why is that?
Because image recognition needs both things. It needs the precise sensory processing, the neural net recognizing pixels and shapes. But it also needs the contextual, conceptual reasoning, the symbolic part, understanding what those shapes represent, what they mean in context. So adding that sort of sub-symbolic pattern finding to the logical reasoning helps get closer to human-like cognition. Lange also talked about different architectural levels, allowing a smooth transition from fast, almost intuitive associative thinking to slower, more deliberate contextual reasoning.
And the benefits are?
Better generalization, for one. More accuracy when faced with new or ambiguous stuff. Faster learning for certain tasks, like classification. It fundamentally allows the AI to handle incomplete or fuzzy input and adapt better, shifting between that bottom-up perception and top-down understanding as needed.
That ability to shift between, let's say, the intuitive and the logical. Does that also apply to how the AI remembers things? Does it make memory more flexible?
It does, yes. That transition capability really helps with creating context-sensitive memory systems. Lange's cognitive research pointed out how crucial context is for human memory cues help us find and understand stored knowledge.
Right, you remember things based on where you were or who you were with.
Exactly. So when you couple that insight with this hybrid approach, you start to get autonomous cognitive systems that are efficient even when things are noisy or changing fast.
Yeah.
And crucially, they retain the ability to interpret their stored memories, not just retrieve raw data. It makes them more robust, more aware in a sense.
Okay, so we have an AI that might reason more like us, interpret its memories contextually, maybe even question itself. What does this mean for the human-AI relationship? For trust, for communication?
This is really a key piece for trust building. Sophimatics uses something called logic-based inverse reinforcement learning.
That sounds complex.
It is a bit technical, but the core idea is powerful. Jaha and Rushby pointed this out. Standard AI often optimizes for a number, a reward score, get the highest score possible. But it often can't tell you why it's chasing that score, what the underlying intention is.
It just does the thing.
Right. Sophimatics aims to use logical specifications for rewards, not just numerical ones, and this is the potential game changer. It means the AI's intention can be expressed clearly, it can be interpreted by us or by other AIs. You can get towards shared intentionality.
So the AI can explain itself.
That's the goal. It could reflect on, articulate, maybe even justify its intentions, its reasoning. Think about negotiation or cooperation, or even tricky moral dilemmas. Unlike a simple rule-based system, these AIs might even be able to express disagreement with a proposed goal and suggest alternatives based on their reasoning. Jaha and Rushby argue that making intentions interpretable is key to resolving preference differences between humans and machines, clearing up ambiguity.
It's moving from just obedience to actual understanding and justification.
Precisely. You get more dynamic architectures that learn and negotiate goals, guided by explicit reasoning and anchored in some serious philosophical traditions.
This all sounds incredibly complex. It really feels like it demands people from different fields working together very closely. Is collaboration central here?
Oh, absolutely essential. You can't do this in silos. Bundy and colleagues were very clear on this in their 2023 work. Developing these more accurate, more human-like AI models requires deep collaboration. Philosophers, cognitive scientists, AI engineers, all working together. Their HLC network, in fact, is built around this idea of getting philosophers and cognitive scientists working directly with AI researchers. And they argue this interdisciplinary approach leads to systems that can reason pretty effectively, even with limited data, which is a huge challenge in AI. Embedding philosophical methods like principles of reasoning or argument analysis directly into cognitive models seems to make them learn more effectively. It also makes them easier to integrate into real-world applications. They're finding examples where these architectures can do things like construct logic programs from just one example by considering principles like specificity and minimality, basically learning more from less intelligently.
And Bundy's team also mentioned emotional and motivational salience, didn't they? Bringing in the human element again.
Exactly. It ties back to that human-aware aspect. By integrating philosophical and psychological insights, you can aim for systems that respond more appropriately in context, more attuned to human reactions. This could lead to more accurate, more reasonable predictions, too. It's moving beyond just crunching data to using data more effectively, more wisely.
It really pushes the boundary, doesn't it?
Yeah.
How much more human-like can AI become in its understanding? So, pulling all these threads together, Sophimatics seems like a really holistic project. It's trying to build a whole new foundation.
It really is. It aims to be an integral foundation, epistemological, ethical, practical. It pulls together the ethical theory we talked about from Langlois,
The hybrid computing systems from Rowley and Lange,
the intentional logic from Jaha and Rushby.
and the interdisciplinary architectures from Bundy.
Right. By making philosophical concepts operational, building them into the code, the idea is to equip AI to handle real-world complexity, uncertainty, even conflicting values. Sophimatics is also intended as an ongoing critique, a way to keep pushing past the limits of purely data-driven or purely rule-based approaches. It's about fostering a reflective approach for AI that needs to be dynamic and ever-changing.
And this naturally leads to this idea of a new kind of professional role, doesn't it? The sophimatician.
Yes, the Sophimatics professional or sophimatician, their role would be to be constantly reflective, critical about these tools, to ensure they keep evolving, adapting to society's needs, really bridging that gap between the humanities and the tech, aiming for technology that's not just powerful, but accurate and truly context-aware.
What an exploration. It really highlights the potential power of bringing these different fields together. Philosophy, cognitive science, computation. It feels genuinely transformative for AI's future. It's not just about processing information anymore, is it? It's about understanding its place, its role, its impact in our world.
Indeed. And it leaves us with some profound questions to think about, doesn't it? If AI can truly learn to interpret, reflect on, maybe even justify its own intentions and values, what new kinds of collaboration, what shared understanding could emerge between us and machines? What does it really mean for us to understand an AI, and perhaps even more intriguingly, for an AI to understand us in this evolving landscape of intelligence?